Hello and welcome back. Firstly, as ever, thank you very much for your comments and feedback on the last video, and let's get on with the next. What I'm going to do in this video is put a sprocket change access hole in these pair of cases. I'm waiting for material on for the crankshaft, for the long stroke crankshaft, so this is a little job that I will be doing on my cases for that engine, but this is a friend's engine and he has asked me if I can put in the access hole for a cover here, so I'll be getting on with that. So I'll give the mill a decent clean. I know the table's flat and level from the last work I've done, so we'll get on with it. Thank you very much. To do this job, I'm going to first of all mount this lower half of the casing securely, can hardly say it, to the mill. Then I can centre up on the gearbox output shaft here, zero everything on the machine, and then assemble the next casing to this. And I know I'm centered over the shaft center, and I'll be boring the access hole true to the gearbox shaft center line. So first job as usual, just make sure we haven't got any nasty lumps and bumps on that face. I'll just very carefully go over with an oil stone and feel if there's any burrs, lumps and bumps that mean it won't sit nicely on the mill. You can immediately feel if you hit a high spot when doing this. As I say, this set of cases belong to a friend, and it feels like he's already made sure that's all good. So let's take that off and get that clamped down. I've got a couple of decent clamps on this now, one through the main bearing bore. Used a couple of spreader plates to make sure I'm not clamping on the inner race. That's on there. Another clamp here on the rear engine mount, and put a little screw jack underneath to make sure I'm not distorting the casing there. I've just nipped round with a 1/2 thou feeler gauge, just make sure I've got no gaps. That all seems good. And as a final check that we're sat nice and flat, I'll just have a little look round with the clock. So let's zero that there, and have a look at a few other places. Minus 1 thou roughly, zero about there, getting as deep as I can. Minus 1 thou about there. If I'm very careful and try not to get in your way. Minus a couple of thou there. It does appear to drift away to about minus 4 thou there. But it doesn't surprise me with these old Cub casings. I often find them all over the place. Just going back, checking I've not knocked the clock. Nope, that's all good. And that is pretty good. Now we're going to clock up and get centered over the center of this main shaft bearing. So let's get the clock down. I've got a nice touch on there. Park that at 0. We're nearly a complete rev of the clock out. So let's go back, split the difference. 0 there, and it comes back to almost exactly 0 there. So if you now go at 90 degrees, take that to 0. Now see, we've got 0 there, 0 there, 0 there. So that's all nicely zeroed now. The digital dials 0, and also the machine's mechanical dials zeroed as well, just in case lose power to the DRO and that loses its datum point. So we can drop that clear, take the clock out. And we'll get the other casing on. And get some bolts in. Once we've zeroed everything, we can get back on centre. Just give myself room to tighten up some of these bolts. That's pretty good. Just nip back on centre here, and out of interest, clock up the bore in that casing, see how in line it is. Right, back on 0. As I say, this is more out of interest than anything else. It wouldn't surprise me if there's some error. As I say, these old casings, I don't know how good they were when they were first made, but they could have moved in their 60 years or so of life. But the most important thing is actually that we're aligned with the, excuse my hands in the way, with the gearbox bearing. Put that there, just zero it. Let's have a look. Certainly not appearing very round, but we might be sitting a bit on that rubber seal. Try and move away from that. Try and get the clock only just to engage. There we go. So about 2 thou in that direction. Well, it's certainly not round. And the worst deviation is 4 thou. But as I say, most important we stay centred on the gearbox bearing. I suspect that bore is rather worn. I was only curious more than anything else. I'll whip the clock out again. Thinking about cutting metal. I've added another support just under the casing here and a clamp over the top just to give this a little bit more support and to stop it ringing when I cut it. So we're just going to nip that up lightly. It's not going to do a great deal. And that should be us ready to start machining. Right, I've packed a bit of tissue paper over the bearing and a bit of card to protect the gearbox bearing from swarf. Let's see how we get on. We're trying to cut some metal. Oh, let's move you so you can see rather than actually just watch my hand. Here we go. Set this roughly to 2.5 inches diameter, and it's got to come out to 2 3/4. May get a bit chattery, we'll see. Just have a quick check on size, make sure I'm near to where I set it. Yep, that's fine. Behaving itself nicely. It sounds like we're nearly through. Yep. And be a little bit careful and let it turn off. No things jam up at all. I'm going to stop there and see if I can break it out rather than it all jamming up and causing an issue. Yeah, there we go. Splendid. Let's just go to a 0 on here. and take a cut so we can check size. So 5, 10, 15, 20, 25, 30, 35, 40. See how that goes. Move out of the way again. Have another quick look. Yep, that took 50 thou off. And we'll find a more accurate way of doing the measurement now, as we're getting near size. Two, 6, 5, 8, that's 40, 90 thou to come out. Right, I'm going to use a bore mic now to check the size of this bore as we're getting close to size, and I want something that I can get an accurate measurement without having to keep moving the slideways back and forward, so I can fairly easily get this in here. So let's see where we are. And get a measurement. I've cross-checked the bore mic against the micrometer, so we know we're about right, and that's nice. And that is 2.6 6 4. Make sure I'm not reading the dials wrong. There you go. 2.665 on the vernier, so that's nice. So we know where we are. So 2.664. So 36 thou should take us to 700 exactly. So let's aim for that. And we are. I don't know if you can see that, but by some coincidence we're exactly on 2.7 millimeters. So if we go another 40 or so, go another 30. I'm getting 736, 735, 736. So that's 14 thou we want to take off. I'll go 10. Well, my camera battery ran out, so you've missed the last cut on this, but we now are nicely at 2.755 thou diameter, so that's 5 thou clearance on diameter over the register on the plug. So the next operation is to just face out over this surface to give us a nice sort of seating surface slightly. So what I've done is I've used one of my slip gauges, a 0.4 slip gauge, to set our distance from this stop to this pin. So we should face out another 0.4 of an inch, which will give us just over 5.5 inches of facing on that. So we'll set up the head to be able to face. I meant 3.5 inches, not 5.5. Which means, first of all, locking that in there and freeing up that pin. Then as the machine rotates, that should face out. We'll move out a fraction. Just trying to touch on. I can hear that just touching on, so we'll wind that back. Take a moment, it's on a very fine feed. Get a clock set. Let's give that a spin. I'm going to zero that. On 10 thou, see how it goes. It's a case of me holding this ring, switching on, and we should be facing out. And there we go. Not cutting all the way around yet, about 60%. Looks like that's going to stop in a moment. Rough measurement. That's well over that 3.5 inches, so we'll stop at that. Drop that back down. Ping that out. Now that's will fairly rapidly return. A little more. That's good. We'll set that up to cut again. Clip that in. That out. We'll drop down another 1/10 out and see how that looks towards cleaning up. Almost there. Right, lift that up. Just trying to gauge how much more I need to go. Need to take that to about 0.8. Oh, looks like my battery went again. So you can see that finished. We've cleaned up nearly all of that area. It just fades out there, which is fine. Got enough surface to seal on nicely. So that's ready for the plate to go in. Just zoom you in slightly. You can see the finished job. Let's get rid of that. And in there. Job done. So I'll break that down, get on with the next thing. Thanks very much. Just finished cleaning up a bit before we break that down. That will do. Put the measuring equipment away and we'll get that unbolted. There we go. There's the finished result. As you can see, cleaned up nearly all the way around, just missed a little here. That's fine. Really don't want to thin this any more than necessary, because you're potentially going to tap some threads in there to retain the plate. So we'll leave that at that. And there we are, one sprocket access hole. Hi again. Well, I hope you enjoyed that, found it interesting and enjoyable. One thing I forgot to mention was, you may have noted I didn't drill any holes for mounting the sprocket access plate around the PCD of the bore that I produced, and that's quite simply because I hadn't got the actual access plate. My mate Joe had not received it at that time, and he just sent me the dimensions, and he's quite capable of doing that, so he will do that when I get the cases back to him. So thanks for watching, your continued support, and I look forward to producing the next video for you. Thanks very much. Cheers.